In this video, we'll be finding limits from graphs. Now remember, when you see holes in graphs, the y value is not there. When x is equal to 5, y is equal to 1, not 2. When x is equal to 2, there is no y value, so y is undefined. Now in this first problem, we're going to be looking at the limit as x approaches 2 from the left side of 2, and we're looking for the limit of this function x cubed minus 8 over 4 times x minus 3. It says that it's equal to 3. We're going to show you why it's equal to 3. So look at this graph. We're approaching 2 on the left side of 2, and we're interested in what the corresponding y values are approaching. Look at the y values. As x is approaching 2 on the left, y is approaching a height of 3. Even though there's a hole there, we say that the left-hand limit is equal to 3. Okay, now let's take a look at the right-hand limit. We're going to get on the right side of 2, x is, and we're going to let x approach 2 on the right side, and pay attention to what the y values are approaching. Again, the y values approach that hole, which is equal to 3. The height of that hole is 3. Even though the y value doesn't exist at 2, remember that the limit doesn't care about what happens when we get to 2. It's only interested in what is being approached. Now, because the left-hand limit and the right-hand limit are both equal to 3, we can say that the two-sided limit is equal to 3. Okay, in this next problem, where our graph is the graph of y, or g of x, we're approaching 2 from the left side. So let's see what the y value approaches. Well, it approaches that hole, and the height of that hole is 3. Now when we do a right-sided limit, the y value is approaching 1. So the right-hand limit is 1. That makes the two-sided limit not exist because the left-hand limit and the right-hand limits are not equal. In this next example, we are finding the limit as we approach 5 from the right side. So get on the right side of 5 and approach 5, and pay attention to what the corresponding y values approach. Looks like they're approaching a height of 2. Left-hand limit is also approaching 2. So the two-sided limit is equal to 2 because the left-hand limit and the right-hand limits are equal. In this next example, we have to approximate our limit because there's no y values on the y-axis, so we're just going to kind of guess what the y value is. The left-hand limit, as we approach 3 from the left side, what are the corresponding y values approaching? Looks like they're approaching approximately -1. When we approach 3 from the right side, the corresponding y values are approaching that hole, which is approximately a y value of 2. The two-sided limit, therefore, does not exist because the left-hand limit and the right-hand limits are not equal. Again, same graph, we're approaching 4 from the left side. So nothing interesting happens at 4 on the graph, but we can still find the limit. So approach 4 from the left, see what the y value approaches. It looks like it approaches approximately 1. Now this is a two-sided limit as x approaches 2.2. And 2.2 is approximately where the graph crosses the x-axis. So a left-hand limit and a right-hand limit are both equal to 0. Okay, in this problem you might get a little confused because the y value is always at -1 on the left side of 0 and always at 1 on the right side of 0. It's not approaching -1, but we still consider it approaching.